Should you consider installing a smart irrigation controller? And if so, which one? The answer is yes. According to the EPA WaterSense program, as much as 50% of the water we use outdoors is wasted. In this video, I'm not going to talk about specific products, but rather what you need to know in order to select the best controller for your system. I will walk you through the important questions you need to ask. First, my simple definition for a smart irrigation controller. A smart controller makes it independent program decisions based on real-time weather and/or soil moisture conditions using the data input information it has received. What do you need to know to select the right controller for you? What questions do you need to ask? Once selected, the setup for any smart controller is critical and will have a significant impact on the efficiency of your system. Here are the important controller selection questions. Will the controller make program decisions based on ET, soil moisture, or other factors? Which approach works best for you? What is ET-based system? What is an ET-based controller? ET stands for evapotranspiration. This is a way of quantifying demand based on 4 factors: wind speed, air temperature, humidity, and solar radiation. It has been around a long time and is well accepted. Many controllers on the market today provide and utilize accurate ET data to make program decisions. What are soil moisture controllers? Soil moisture-based controllers rely on a soil moisture sensor or multiple sensors to make program decisions based on actual soil moisture levels. Which approach makes the most sense for you? Either can work when set up properly. It really depends on the size and complexity of your project. Ask for a specific explanation of why either is being recommended for your site. Will the smart controller selected allow for all the data input needed? Good input like precip rate, sprinkler efficiency, soil type, plant type, root depth, microclimate, and slope are essential. Do your soils require multiple cycle and soak periods for optimal infiltration? If you have clay soils, for example, or significant slope issues, cycle and soak intervals can prevent runoff. Can the controller be adjusted by runtime percentage, either an individual station or a program? This is a great way to fine-tune your system. Does the controller have the ability to use predictive weather to make adjustments? Predictive weather events such as rainfall can produce significant water savings by reacting before rainfall actually occurs. Will it accept a flow meter or sensor and register real-time flow conditions? Flow monitoring can tell you when a problem is occurring instead of finding out days later or when you get your water bill. What flow conditions will it register, react to, and report? Events like high flow, high zone flow, low zone flow, mainline breaks, or unscheduled flow, each of which can waste large amounts of water. Will it accept a master valve, and why is this important? A master valve can prevent water loss when a valve sticks on or there is a mainline break, for example. Will the controller report on system electrical faults? A bad valve solenoid or overcurrent situation can prevent the zone from operating and lead to plant damage or replacement. How will it deal with local rain events? A local rain sensor reacts to site-specific rainfall events. It can be very important when working with a weather-based controller. Does it have the best remote access option for you? Either cell, Wi-Fi, or Ethernet? Which one is most reliable and cost-effective? All of these questions, when you have an understanding of them and ask them, can direct you toward the controller that makes the most sense for you. Data input, management, and monitoring. Once you have selected the controller, how do you make sure that it's producing all potential savings and benefits? The successful ongoing operation of the controller will depend on accurate and complete data input, real-time management decisions, ongoing system performance monitoring, and clear communication between all parties. For example, who is going to set up the initial controller programs and input all of the data required? Will it be the owner, the contractor, or a third party? Ideally, it should be done by whoever is going to monitor and manage the system. Do smart controllers require any oversight? A lot of manufacturers will tell you that once you install them, you're done, but that's not the case. Someone will need to maintain oversight and management of the system. Who will be responsible for all programming, monitoring, and alert notification? Whether it is the owner, the service contractor, or a dedicated water manager, this must be clearly defined. How will communication take place between all parties? Will it be done with text, email, or phone? Will it allow different levels of program access and input, such as owner, user, field tech? Why are different access levels and input tracking important? They can define roles and responsibilities for all parties and eliminate the mystery about who's doing what. What aspects of operation will the controller track? What ongoing information is important to you, and will the controller provide it? Reporting. Producing reports like alarm history on a water usage or a water usage summary will enable the tracking of system performance over time. You can't correct problems if you don't first identify them. What type of reporting capabilities does the controller have? And does this match up to what you're looking for? Will it provide you with the information and feedback you need? Will it record and log program inputs, and by whom? This will enable accountability and help to define the responsibilities of all parties. Will it allow different levels of program access and input? Why are different access levels and tracking important? Example might be you'd like the service contractor to have the ability to turn things on and off when he's providing service, but you don't or might not want him to be able to change programs. In summary, a smart controller can produce significant savings in water and dollars when the right one is selected, set up properly, and managed on a real-time basis. If you would like to know more, have specific questions, or need help to choosing the best controller for your project, give me a call or send me an email with "Save Water" in the subject line. Thank you.